Let's rewrite sine squared cosine to the fourth x as a sum of first power cosine functions. So the thing that I try with this is I notice that this is sine squared, cosine squared, cosine squared. And you could certainly use the power reducing formulas on both of those, on all three of those. But I would prefer to use our double angle formula on this. If we divide this by 2, we get 1/2 sine of 2x equals sine of x cosine of x. And if we square both sides, we get 1/4 sine squared of 2x is equal to sine squared x cosine squared x. And then we have a cosine squared x. Now we can apply our power reducing formulas. So sine squared of 2x is 1 minus cosine of 4x over 2. And cosine squared is 1 plus cosine of 2x over 2. Pulling those out gives us 1/16 times 1 minus cosine 4x plus cosine 2x minus cosine 4x cosine 2x. Now, last thing, this is not acceptable because we have cosine cosine, and it's not a sum of cosine functions. So we can use our power to sum rule. Say that this is 1/16, 1 minus cosine 4x, cosine 2x, minus, this is 1/2 cosine of the difference plus cosine of the sum. Finishing this off, we can factor out this 1/2, getting 1/32, and then we have to multiply each of these by 2. So we get 2 minus cosine 4x, 2 cosine 4x, 2 cosine 2x, so that was in order to get rid of the negative 1/2, minus cosine 2x, minus cosine 6x. And finally, we can combine like terms because there's these two. Our final answer, 1/32, 2 minus 2 cosine 4x plus a single cosine 2x minus cosine 6x. If you want to be nice and neat, you can write those in order, which would be this order or the opposite order, based on the angles increasing or decreasing as you prefer. So that is rewriting it as a sum of first power cosine formulas.